amines. As you all know, the functional group in amines is the NH2 group. So this is basically derived from ammonia, that is NH3. Ammonia contains 3 hydrogen atoms, in which hydrogen atoms is replaced by the alkyl group. They will be forming the corresponding amines. So we have 3 hydrogen atoms in ammonia. We can replace 3 hydrogen atoms by R group. If one hydrogen is replaced, then it is known as primary amine. That is example here CH3 group, NH3 ammonia, in which one hydrogen atom is replaced by CH3 group, that is primary amine. And also CH3 or C2H5 group, that is alkyl or aryl group, can substitute the hydrogen atom. If 2 hydrogen atom is replaced, then it is secondary amine, and if 3 hydrogen atom is replaced, then it is the tertiary amine. So we can replace hydrogen atom by both alkyl and aryl group if corresponding amines will be obtained. If all the alkyl or aryl groups are the same, then it is known as the simple amine, and if they are different, that is both alkyl and aryl groups are present, means it is known as the mixed amine. It is coming to the structure of amine. We know nitrogen has 5 valence electrons. Then here nitrogen is sp3 hybridized and forming 3 sigma bond with the hydrogen or alkyl group or aryl group, and 2 electrons are present as the lone pair of electrons in an unhybridized p orbital. So this have a pyramidal shape instead of a tetrahedral shape. Each 3 sp3 hybridized orbitals of nitrogen overlap with the hydrogen or carbon atom and forms CNH bond, which is usually it will be 109 degree, but here it is 107 degree. So here this nitrogen forming 3 sigma bonds with R group or hydrogen group, and a lone pair of electron will be present in the sp3 hybridized orbital. Bond angles in primary amine is 107 degree, secondary amine it is also 107 degree, but in the tertiary amine it is 108 degree. Since here all the sigma bonds are attached to nitrogen is R group, so there will be interactions, group interactions between the alkyl groups, so bond angle is also increased. And coming to the preparation, first one is ammonolysis of alkyl halides. Alkyl or benzyl halides undergo nucleophilic substitution reaction with ethanolic solution of ammonia. So here halogen atom of the halide is replaced by the NH2 group. The process is known as ammonolysis. The reaction is carried out at 373 Kelvin. This is a continuous reaction. That means if a primary amine is formed, that will further reacts with the alkyl halide and forms the secondary, tertiary amines, etc. So in the first step, ammonia reacts with the alkyl halide and forms an substituted ammonium salt or NH3 plus and X minus, which on treating with a base sodium hydroxide, corresponding primary amine will be produced. The primary amine further reacts with RX, forms secondary amine. Further reaction with RX gives tertiary amine, and finally reaction with RX gives the quaternary ammonium salt, that is R4N plus X minus. So here we can produce a mixture of amines like primary, secondary, tertiary and quaternary ammonium salt. The reaction depending upon the halogen atoms present. So if Ri is present, the reaction will be high, and coming to next RBr, and last one is the RCl. Thus halides reacts with or bulkier halide will react fastly with the and forms the corresponding amine. Next one, preparation by the reduction of nitro groups. Nitro groups, both aromatic and aliphatic, can be prepared by reducing in presence of hydrogen and palladium ethanol. Nitro group will be reduced to corresponding amino group. Reaction can be carried out in presence of metal and HCl. This is also leads to the formation of corresponding amines. And the iron and HCl combination will be preferred for aliphatic compounds, since FeCl2 formed gets hydrolyzed and releases HCl during the reaction. So here minimum amount of HCl is needed for the reaction. Next one, reduction of nitriles, cyanides RCN, reduced in presence of lithium aluminum hydride to corresponding RCH2 NH2. The reaction can be carried out catalytically in presence of H2 and nickel, or sodium amalgam in ethanol. The corresponding product will be obtained. Next one, Hofmann bromamide degradation. Here the reaction is carried out in presence of a base and bromine. Primary amines are prepared by treating with an amide with the bromine and ethanolic or aqueous NaOH. And the degradation reaction, here the migration of an alkyl group from carbonyl group to the nitrogen group takes place. Nitrogen atom takes place, and the amines formed containing one carbon less than the corresponding amide. So here RCONH2 is the amide taken, which reacts with the bromine in presence of a base, and corresponding amine, that is RNH2, will be formed, which is having one carbon atom less than the corresponding amide. So here R also, if CH3 means there will be two carbon atoms, but in the amine there will be only one carbon atom, that is one carbon atom less than the parent amine. The same reaction can be carried out in presence of P2O5, and reducing that one with the lithium aluminum hydride gives the amine which is having the same number of carbon atoms. So amides can also be reduced in this way to produce the same number of carbon atoms as the parent amide. Next one, Curtius reaction. Here amines are prepared by treating acid chlorides with the sodium azides, that is Na and N3. And the reaction gives an isocyanate, which on further hydrolysis gives the corresponding amine. So from acid chloride RCOCl treated with NaN3 sodium azide, acyl azides will be produced, RCON minus N plus double bond N, which on heating nitrogen will be eliminated and corresponding isocyanate will be formed, RnCO, which on hydrolysis in presence of a base, corresponding amine will be produced. The reaction is known as Curtius reaction. Schmidt reaction. Here carboxylic acids, ketones or alkenes react with hydrozoic acid, that is HN3, to give corresponding amines. So, and ketone R1COR2 react with hydrozoic acid to give R1CONHR2. So NH group will be inserted in between R2 and CO group. An alkene R1CH2CH double bond CHR2 reacts with NH3, gives the R1CH2CH double bond NR2. So nitrogen will be inserted. Then acid R1COOH reacts with HN3, gives RNH2. That is the primary amine will be obtained here. So acids will give primary amine, ketones will give the secondary amine, and alkenes will give the tertiary amine. Then preparation of secondary amine. Here by the reduction of isocyanide in presence of sodium and ethanol, CH3NC plus 4H gives CH3NH CH3, and triple bond C will be reduced and hydrogen will be substituted there. Second one, by heating the alcoholic solution of primary amine, C2H5NH2 with the alkyl halide C2H5I gives C2H5 twice NH. Secondary amine will be obtained here by revelation of HI. Preparation of tertiary amines from secondary amine, when treated with C2H5Cl, here HCl will be eliminated and hydrogen will be substituted by C2H5 group. This is the tertiary amine. Another method, by hydrolysis of quaternary ammonium salt, when treated with silver hydroxide, I will be substituted by OH, and which on heating gives a tertiary amine C2H4, and water will be eliminated. Next one is the preparation of quaternary ammonium salt. When tertiary amine reacts with haloalkanes, corresponding quaternary ammonium salts will be obtained.